Okay, let's look at your 555 timer. Up close, you'll see that there's this little tiny dot. Let's see, what can I point with this dot to? That right there. See that little dot? It's a little bit shinier than the rest of it. This is your pin 1. Okay, so pin 1, I'm just going to put this down in my breadboard like that, and you can see that is what? 10. That's what's really handy about these numbers. You can kind of think of this as row 10 it starts with, and 10 on the other side. On the schematic, it doesn't really state the exact same thing. You'll see that this is the schematic variation of the 555, so it's not like pin 1 is here, pin 1 is shown here, pin 2 is shown over here, pin 3 over here, 4, yeah, etc. and so forth. So definitely not the same. But you'll look at pin 1, so this is pin 1 through 4, then on the other side it starts 5 through 8. Okay, so what else? Well, we're going to need, and I'm going to transfer some of these from this to keep the speed up on this video. Certainly we could worry about cutting wires and all that other stuff, but really that's all on you as far as the cutting wires are concerned. I don't want to cut wires in the video. That's very boring to watch. Let's look at, I always start with pin 1. So pin 1 goes to this line that's not even dictated, but in this line, this is my negative line. And how do I know that? Well, I know my positive is up here, and with pin 1 you can look at the schematic on the back of this and you'll see pin 1 is ground. Okay, so this is the package the 555 timer came in. So that's how I kind of look at things is, you know, if I can't find it on the schematic, I'll look at the chip, and the chip says ground, so therefore in the schematic this is going to be my ground. Alright, now, so I'm going to keep this blue line my ground, and I need to connect that pin to there. Well, alright, so no big deal there. In this case, I just make sure blue. Is connected to the ground. There we go. Just like that. Ooh. Alright. Now, it gets a little hectic here, so let's look at maybe my positive side rather than go pin 1, 2, 3, 4. Where's my positive pin that's always positive and I don't have to worry about it, and it's right here, plus VCC. In this case, pin 8. And you can see pin 8's a switch. Alright, well, how do you handle a switch on a breadboard? Well, that's kind of fun. Okay, if you look at this breadboard, we have the switch where there's the positive, it goes in and then back out and then onto the pin. So let's do that real quick. I'm going to steal parts from this one. So we're going to pretend that the battery is hooked up here in that little hole. Excuse my little nimble elf fingers, can't get this stuff. In fact, as a nimble elf fingers would help, I have these huge button paw hands. So that'll work right there. Cool. Okay, add the switch, and the switch works sort of like this. where this pin, when pushed down, will go out this end of the actual switch. Okay. Just like that. Okay, so I'm going to move my switch down just a little bit because my wire's not long enough, and that therefore I have to move this one down. Just like that. Okay, red, boom, into the switch, boom, into the one. Perfect. Back to the schematic. Okay, now there's the switch. Hey, there's something hooked to this also. You can look at this line. See how they're broken up here and here, but 4 and 8 are connected to this switch in some way. In some cases, you're going to look at a schematic and you're going to see a little dot, kind of like this. Depends on what schematic you get. So those dots indicate a connection. This schematic didn't have the dots, so I'm just going to kind of know that the broken area means no connection. Alright, well, what this means is this. Steel apart. That means pin 8 is connected to pin 4. Just like that. Okay, let's go back to the schematic. Now that I got positive and negative down, you know, that I wanted to attack that, and it's all different for everybody's brain, but some will just start at pin 1 and work away around the chip. I like to look at pin 1 and then I'll look at whatever is the polar opposite, like negative and positive is another way I handle things. But really I try to take out the easiest to understand stuff first and then go about it that way. Alright, so what's another easier to understand thing? Well, I know these jumper wires work just like that, this one right here. So let's look at another one that's kind of like that, and there's a 6 and 2. Okay, so 6 and 2 are connected directly. Alright. Six and 2. Pin 2, pin 4, or no, 5 and 6. So 4, 5, 6. Just like that. So that was an easy connection. Okay, let's look at another connection. There's a resistor that runs from pin 6 to pin 3. The 33K one. You can see how it's going underneath this one and connecting over here. So pin 6 and 3 has a resistor value of 33K. Pin 6, pin 3. Now, you should look every once in a while to see what these pins do. We'll do that here shortly when we get the circuit built, but I will say pin 3 is your output. Okay. Alright, next, there is a 1K resistor going somewhere. It's coming off of 3 and going somewhere. Alright, so that is into your transistor resistor, in your transistor. Alright, in this case I have it kind of like this, so I'm just going to steal this one. And pin 3 going somewhere. So this is what I have so far. Study it, look at it, and we'll continue. Alright, now just so we're still on the actual 555 timer, let's complete that one out before we get to the transistor. There was a 100N here and a 10N capacitor. Alright, the 10N goes from 2 to ground. So I know 2 is going to be a positive because a capacitor stores energy, so the ground and the positive would store energy in this region. That's another way to tell if something's positive or negative. I look at the cap value, and if the cap is connected to it via the chip, so 5 is going to be a positive in this case and 2 is going to be a positive, I know those are positive outputs. Okay, not to get all nerdy, 2 to ground. Okay, so pin 2 to ground. Notice there's a lot of stuff hooked to pin 2. You can see that there's a capacitor down. There's a jumper to 2 to 6. Okay, even though the schematic 2 to 6. I gotta also 33K resistor. So this stuff is really cool to read once you get it down pat. Okay, 100N to 5. Battleship. That's what it reminds me of. Battleship. So pin 5 to ground. Just like that. Alright, now we have reached past the 555 timer. Have everything we need for it. Now we have to look at the transistor. Alright, in this case, all that information from the circuit, from the IC 555, is being translated to a base. And the base will dictate whether energy goes this way or this way. So it's coming in from a transformer. That's the collecting value, and being emitted out to ground. But is it? And that's the secret of the greatness about this circuit is what it does is you can think of it as a Pringles can being stored with springs. Okay, it's storing energy here in the caps, but every once in a while it cycles through and says, nope, you're going to ground, nope, you're going to the cap, nope, you're going to ground, nope, you're going to a cap. Over and over, very quickly, billions of times a second. And what happens is all these cap values load up very quickly because of that. And once we get to this multiplier and explain that to you, ooh, it's good stuff. Alright, so base. Where's the base on this stupid thing? Base is located on pin 1. Pin 1, if I face it towards me, like that, it is the first pin on this side. So the first side, so pin 3 needs to be connected to base, just like that. Well, what about these others? The other two? Well, the other two, it looks like one, the emitter, is connected to ground. That means on this one, I would run jumper. Whoa. All my parts are like seriously squashed now. Hold on while I straighten them out. That's what I like about the breadboard thing. You know, all these little parts come off and play with it later. There we go. The negative value is hooked to the third pin on the transistor, which is your emitting value. Next, your collecting value. Your collecting value is going to go over to a transformer. Oh, so now is a whole new world, Grandma. Transformer. I mounted my transformer on a little piece of perf board because I use this a lot in other circuits. So I've learned that, you know, if you want to just like play around with this stuff, I always try to think of a way I can mount it to a perf board. That way it sits down into a breadboard and I could take it in and out. So the transformer is a whole different thing in the fact that, you know, I mounted it to a perf board, but really all it is the white and red wire on one side hooked up to these two pins so they sit down into the actual circuit or breadboard, and this side is my blue and green wire. Okay, the black wire is being ignored in this case. Cool, cool. Usually what happens is this side gets hooked up to the electricity and then out comes information for your, you know, speakers and stuff. But we're actually hooking this in reverse. So this side has the energy and this side gets the output. Therefore reversing the current from a DC to an AC. Alright, so that's the advantage of mounting it on a perf board like that. You could actually take this, take the wires apart, cut them right here, make them real short, and then what I do is usually solder the ends so they're a little bit stiffer because this wire is pretty wussy, and that way it fits down in your breadboard. So you can do it that way too. These little pins, you can actually make those if you wanted to out of like this wire right here, or you can buy just like really stiff wire. Has to be like 24 gauge, I think, to fit down into a breadboard correctly. Alright, so that means I'm just going to set this bad boy down in my breadboard and provide enough space so I can get in here with my mutt and paw hand and over here with my mutt and paw hand. And I can see where those are at. And I need to make a connection between the collector and this first pin. Now it doesn't matter if it's the first pin or this pin over here, but since this is closer, I'll make a connection between the middle pin and that one with a wire. And I cannot show this via video and still look at it. Sorry. There we go. So it works just like that. Now what happens here on this end? Well, this gets hooked all the way to positive. So we straighten this little bad boy out. Again, not enough dexterity to do that at the same time, but I will say it goes there, so it's the second hole in. So I'm going to remove my transformer. Push the wires down and seat my transformer back into position. Perfect. There's your DC side of things. Okay, now we'll mount two more wires and then we'll stop and look at another video here about the voltage multiplier. So that doesn't matter what color wires you use, I just use two different colors. In this wire that I have, I got black, yellow, and red. So sometimes anytime I'm thinking about how energy is changing, I'll use a yellow wire, and when I know it's going to be positive and I know it's going to be negative, I use a black wire. That's my color schema of wires and how it works in my brain. Okay, so there's that. Let's look at now this side of the circuit, the voltage multiplier, in the next little video.